So, Summit, is that right? That's what we're here for, right? You even got the t-shirt there. Okay, well, my name's Alan Bradshaw. I teach physics here. If you haven't taken physics yet, you should definitely come over to Harlan and do that. You're all going to line up we'll get you in. I'm here to talk about leadership in the sciences. So I'm going to need a little help. I want to describe the way I feel about this topic. I guess I could have just tried to communicate it in words, but I thought that this scene, if I can get this to play, no, I can't. Netflix is so picky about what they show when start trying to project it and doesn't like it very well. I'm going to try this though. Y'all watch The Office? Yeah. There's a scene from The Office where Michael Scott, this might be a spoiler for you if you're watching it through now, so kind of bear with me. There's a scene from The Office where Michael Scott starts his own paper company. And they are doing really well, stealing all the business away from Dunder Mifflin until they go to see their finance guy. And they say, okay, so we need to know whether we can hire a delivery man. And the banker says, well, if the numbers that you've given me are correct, how much can we afford to pay me? The numbers that you've given me are correct, you can't afford to pay him anything. You're going out of business. Your prices are too low. And Ryan pipes up and he says, no. I checked all these numbers out myself. We just have to go through a few months low prices, and then we'll turn a profit eventually. And the banker says, well, yeah, with a fixed cost pricing model, that's correct. But if you use a variable cost model, then you need to do your numbers that way. And Michael looks at him and he says, okay, well, why don't you explain what you think that is? Ryan says, yeah, explain what you think that is. That's exactly the way that I feel right now. Leadership in the sciences. First of all, if we talk about, let me apply that question to what this class is first, okay? Summit. What do you think that is? Let me get you to help me out with that.
What do we think Summit is?
Yeah, we'll get there in a minute. But first of all, what are you even doing here in the first place? Let's deal with that question.
Well, I guess we're here to learn about leadership and learning how to apply it, right?
Learning about leadership and how you might apply it in whatever field you're in. Okay, that's pretty reasonable. Then, when you think about leadership from a scientific perspective, why did they bring in a scientist to talk to you about leadership? That would be a good question.
It'd be awfully weird to have someone who works in marketing talk about leadership.
Okay. It might not be weird to have somebody in marketing talk about leadership, right? But for them to talk about leadership in the sciences might be weird. Okay, I get that. Why else? Why else might it be helpful for you to know something about leadership in the sciences? Who in here is majoring in the sciences? Some kind of science, okay? About half the room sort of pertinent in that. What were you?
Just a lot of times we get business classes or like in stuff that doesn't really apply to biology and understanding.
Okay.
Perspective.
Okay, helpful to have the perspective of somebody who understands leadership in the sciences. I'm so sorry to disappoint you, because I really, okay, I kind of understand maybe why they might think I would be qualified to talk about this. I am the chair of the physics department. It's a 2-person department. I'm one of the 2 people. But I don't consider myself a leader. I really don't. At least not in that sense. Not in the sense of the sciences. In fact, when I think of a leader in sciences, I think of somebody who's in charge of projects, or in charge of research, or in charge of doing something. Maybe in charge of a physics department. But if I think of a successful leader, I think of somebody who's really successful in what they do with that leadership. And I don't know that I'm all that successful. I think maybe they should have gotten Kent Gulliver. You know, he's the chair of the biology department. And that's a really successful department. You know, despite the fact that biology is a terribly boring subject to study. I don't know why anybody would want to major in it, but people do. And people really do major in biology, and a lot of people major in biology. It's our biggest department on campus. And Kent has done a phenomenal job of leading that department. And really, he's done some things in it that have been very innovative and have kind of changed the culture for what biology is. They should have gotten him. But they probably did ask him, and he said no. So you're stuck. It is an important issue, though. And that is something that has become clear to me as I've kind of tapped into my extensive expertise when it comes to scientific leadership, by which I mean I did a Google search. It became really clear that scientific leaders are something that's needed. At least I found one article that said they are. In Forbes Leadership, the 3 types of leaders the world needs most: artistic, scientific, and interpersonal. I think they're talking about 3 different types of people there, although I'm not completely sure that those 3 are completely independent. But they kind of define the term there, and I thought that was very helpful because I needed that. I needed to know what do they mean by a scientific leader. A scientific leader guides and inspires by influencing knowledge with their thinking and ideas. You can find them creating new technologies, doing research and writing, teaching, and the like. Their ideas tend to be well thought through, supported by data analysis and logical. These people develop structure and frameworks to help others solve problems. And maybe that's why I don't feel like I'm a scientific leader, per se. I identify with the solving problems part. I really love research. I do research. I have a research program that I'm still involved with at Vanderbilt. We're looking at the magnetic fields of the stomach and the small bowel. We're dealing with issues that a lot of people have with the GI system. The gastroparesis is one of the diseases we're dealing with. We're now getting into chronic nausea. It turns out that a lot of teenagers especially have this uncontrollable nausea that doesn't have any known cause. And there's no good way to characterize it. So we're beginning to use some of our knowledge of physics and the way that you apply physics to medicine in order to assess what's going on with with some of these people who are experiencing these kind of debilitating gastrointestinal. And, you know, what really fascinated me about this whole idea, when we first got into it, you know, I've trained in physics, and honestly, the last biology class I had was in the 9th grade in high school. I haven't had a biology class since then. Don't tell Gallagher that. But I'm considered a biomedical engineer or a biophysicist because I've picked up the biology that I've needed as I've gone through from people who study biology, from doctors and surgeons. I've worked with a lot of surgeons on this thing. And it fascinated me that you could take the human body and apply the principles of physics that I've been trained in, you know, and learn something and create something new, something that hadn't been created before. And so, you know, I've actually got a patent with my name on it. There have been some really interesting developments. That patent and the dollar would buy you all of them. But, you know, it's been neat to do some things that nobody's done before. You know, even if nothing ever comes of my research, just to have done something for the first time is really kind of a cool thing. And so, in that sense, maybe I would be considered a science leader. But when I think of, who do you think of when you think of science leaders? Actually, let's answer this question first. Put that question in the back of your mind. But ask yourself first, why do we need leaders in science? And maybe a couple of those images evoke a possible response. Why would you think? Yes, sir. Calvin.
Innovation,
For what? For what purpose?
advancement of the society.
Yeah, because we don't want to be stuck where we are, right? We know that we need to be at the next level. And the ideas that scientists are generating may take us somewhere that we maybe haven't conceived yet. What else? The question of why.
Kind of like from the pictures, there's a tendency for people to use science for selfish or violent reasons, ways that don't progress mankind in any way, actually set them back. And if they don't have leaders, then there's really, you know, the people, I guess, will use science how they want to.
Quite right. Science becomes very politicized sometimes. And even twisted away from its original intent or even from what is known to advance someone's own cause. You know, the no nukes cause is a really fascinating cause to me because what they're saying there is not no nuclear weapons. That's not a protest about nuclear weapons. It's a protest about nuclear power. That is in response to the renewal of the Fukushima plant in Japan. You all remember what happened there? Big tsunami wiped out the nuclear plant. And it was a bad disaster. It was a bad environmental disaster. They've got near that plant shut down for a good long while. And so these people are protesting the what do you call it? The coming back online of the Fukushima plant. On the other hand, there are a whole bunch of former environmental activists. I guess they still call themselves environmental activists, but they used to be anti-nuclear, who have really looked into energy and have asked themselves, where is our energy coming from? And what they've found, what they've concluded is that our oil-based, petroleum-based energy industry is actually much more environmentally harmful than the nuclear industry. And so if you go on Netflix, you can find a documentary called Pandora's Promise, and you can read about or watch the conclusions that these people have come to as they've kind of shifted their view by studying the science. So that's one thing. And then, you know, there's a whole lot of scientific information and misinformation out there. You know, National Geographic calls it the war on science. Climate change does not exist. Evolution never happened. Moon landing was fake. Vaccinations can lead to autism. Genetically modified food is evil. All of those are suppositions that people make, or propositions that people make, that science would have a different take on. And so we need to have some scientific leadership to bring some clarity to the ideas that go on. Anything else? Any other ideas like that? This I totally agree with. This is in the journal Nature, a comment. Science professors need leadership training. Definitely. You know, if I'm considered a leader, it's a scary thing. It's a scary thought. I never had a class like this. I never had anybody sit me down and say, here's what you need to think about if you're going to lead a project or lead people or do anything in which you are in authority. I just kind of got thrust into those roles as they happen. And so I think that would probably be a good idea. Now, let's talk about who. I've given you a couple of minutes to think about this. If you think about leaders in science, okay, who do you think of? Who comes to you? Besides Dr. G, I know.
Elon Musk.
Elon Musk. Okay, explain who Elon Musk is.
Looks like he's outrageous company.
Elon Musk is the 22nd richest man in the world. Yeah. And he does what?
Looks like he's probably like the next project is like the space station.
Okay. He does everything. I mean, he has a finger in everything, but he's the president of Tesla Motors. What else? He started PayPal. SpaceX, that's the one I was trying to think of. Yeah, SpaceX. He is into everything. Yeah. If I wanted to follow, and I appreciate that, Calvin. I think that's a great example. Let's say that I wanted to follow in the footsteps of Elon Musk as a scientific leader in the field of science. What kind of training should I pursue? Y'all know? What good is my PhD in physics going to be? Did he get a degree? I think I might be wrong about this, but I think he got a college degree. He started a PhD program at Stanford. Does this sound right? And then he dropped out. He went there for like a week or so, and he decided, this is a total waste of my time. I'm going to go be president of Tesla Motors and create a company called SpaceX and do interesting things. So I'm not really going down the right route if I want to be like Elon Musk. But definitely a leader in the field of science. Who else?
I think it's the head of the Human Genome Project.
Okay. The head of the guy who headed up the Human Genome Project, who is now the director of the National Institutes of Health. What's his name?
I had to Google it, but Francis S. Collins.
Francis Collins, yeah. Definitely, he's actually the guy that came to my mind first. Yeah, Francis Collins. He's the head of the Human Genome Project, the current director of the National Institutes of Health, which means that he controls something like $13 or $14 billion in research funds for health-related research. And a committed Christian. Very interesting guy. Now, if I wanted to follow in his footsteps, I need to do a lot more training. Because he did a PhD in chemistry, and then decided he needed to go on and get an MD. And it was during his residency that he actually started questioning his atheism. He was an atheist at that point. He started asking himself, who is God? But yeah, what a fascinating career. Figured out, sequenced the human genome. I mean, that right there is a pretty good resume point, right? But then went on to direct the National Institutes of Health. Great. Who else? brains here. Let's think. Who can we come up with?
Albert Einstein.
Okay, Albert Einstein. Not alive, not current, right? But unquestionably one of the leaders in the field of science, right? Now, was Einstein a scientific leader or a scientific pioneer? Or are those things the same? You see what I'm getting at?
I would say he was a leader because of his stance against some of the things that his research was being used for.
Okay, definitely. He took some very strong stands, right? And he recognized that his genius in science made him an authority. And so he utilized that. He wrote letters to the presidents, he met with presidents, you know. Very much embraced that position as a leader. Realized that he had a responsibility as a public figure. But first, before that, he did some really innovative things, right? He made us think about the whole nature of everything in a very different way. Brought a very different perspective to everything. Okay, yeah.
I'm not even sure if I'm pronouncing it right, but Minaj Varghese, the CEO of
Where?
5 Hour Energy.
5 Hour Energy. Wow. I've heard that name before, but I had not realized that. So what makes him a scientific leader?
Well, he's an entrepreneur, so he's a businessman, but he's also a philanthropist, and he does work with like engineers to like solve world problems, like regenerating water without using any energy, and then also creating a bike that if you just bike for an hour, it powers like an entire house for a whole day for 24 hours.
That's so cool.
So it's just like pretty neat.
Yeah, that's great. Great, innovative ideas, you know, new ways to think of things. Anybody else? Okay, I've got to stop, and I'm going to go back to my original question. Remember what it was? What do you think that is? I need to know a little bit more. Now, explain Summit to me. You all spent 4 days, was it, in Georgia at a conference center, right? Doing what? Listening to people, okay? Tell me about some of the people you heard and some of the lessons you learned as a result of that time.
David Scobie, the president of the board, spoke about personality types and how to interact with those that you're leading and how to best organize them for success.
Can I just write that down? Personality types, all right? David Scobie is one of my heroes. I would consider him a leader in science. What's his resume? What did he used to do?
He was president of Southeast AT&T.
Pretty impressive guy. What else? Who else? What else?
We heard from Brittany Turner, who is the founder of Aerial Development. She talked about sort of personal plans and how if you want something to happen in 25 years, you'll figure out what you're going to start and stuff in the next 90 days. So.
Oh, wow. So my 10 to 25 year plan needs to start today, and by, let's see, April, May, I need to have them figured out.
Not necessarily figured out, but you can't expect something to happen.
If I haven't started. Okay. Interesting. See, all of this is great advice. I would not have this to give you, so that's why I'm asking. I need to learn this stuff.
Tim Shaw was another one.
Tim Shaw, tell me about Tim.
He was a linebacker in the NFL with Kansas, and he's done this scale
What did Tim bring to the conversation?
He was actually interesting. The day before Brittany spoke about plan 25 years in advance, and he was kind of like, that's good.
Here was my 25-year plan.
Yeah, here was my 25-year plan. Here's how it works out. And so he's like, you can plan what you want, but sometimes it doesn't always work out. And he was more kind of like how you deal with that and how you lead as a servant in your faith.
Okay. Very good. What else?
talked about servant leadership and being willing to like get your hands dirty and kind of menial work, and not just like be just a coordinator that's at the top.
Okay.
Helping like the lowly and the low.
Okay, okay. So the idea that you lead by serving. Anything else? What else did you come away with? I know y'all are nervous to speak up because they're taping this for whoever hasn't seen it yet. So your responses may get, but talk freely. Pretend like they're not taping. I promise, no consequences will come.
Randy Lowry talked about courageous leadership and how sometimes you have to do things that might make you uncomfortable or that you don't want to do.
I mean, and he's a great one to talk about it. You know, when he came to the university, he brought a lot of ideas that we hadn't thought of before, that were kind of revolutionary in some ways. And there were a lot of people who were like, yeah, is this going to work? I don't know. You know, the proof is in where we are now versus where we were then. And yeah, sometimes courage and being able to see past people's fears and people's objections can really be helpful. Anything else? Those are all really good.
You talked about the difference between influence and power. How like influential leadership be empathy.
Okay, so influence has more to do with being able to identify with who you're leading, and power is just maybe unilateral. I don't care what you think. This is the way it's going to be. Interesting. Now, how do all those principles apply to scientific leadership? What are the similarities and differences that you see? If you just think about generic leadership, these are the characteristics of a leader. How does that differ, or how is it the same from what you might see in the field of science? Are there differences? Do you have those same?
Think about courageous leadership. We talked about Dr. Lowry, how he had some ideas that were pretty bold and hadn't necessarily been done before. He was thinking outside the box. I think in the area of science, that's how a lot of the great inventions that have pioneered science that we have today happen. People thinking outside the box and being unafraid to go after it.
Absolutely.
I feel like the principles are the same no matter where you're applying it, but the situations are very different.
Oh,
So
okay.
therefore the execution is very different.
Yeah, the way that it comes out. Like, look at it. What would you, well, let me hold that question. Let me show you what I found here. Again, do the thing. I found this New York Times page called Profiles in Science, which you guys can't see, can you? And actually, it turns out I can't see it. Well, I can kind of see it. I don't know why it's not displaying. There was something up there just a minute ago, though, wasn't there? Before I- Got that. Okay. Now you can see that, right? So these are some of the people that the New York Times would consider movers and shakers today in science. Michael Dickinson, who has spent his whole life studying fruit flies. How many of you were biology majors? What's the class that you have to study the fruit flies? Genetics. And you've done that, right? So you've been studying fruit flies. This guy studies everything about fruit flies. So, what's the experiment you do with fruit flies?
We have several different genes and we see how they are inherited.
Okay. He does that. He builds models of fruit flies, models that actually fly, of how their wings flap. Does computer simulations of why they move and how they move. Studies the neurotransmitters that they're using. Interesting guy. These people research the brain's GPS. How does the brain know where it is? This guy is looking at guinea worm disease in Africa. This lady's really interesting. She's looking at telomeres. What's a biology again? What's a telomere?
It's like on the end of a apple.
It's the end of what? Of a chromosome. And what is the importance of it, the significance of it? She's finding short telomeres that...
It protects your gene. It's basically a bunch of repeated sequences that don't mean necessarily anything other than they protect what you use to encode others.
Okay.
Their coded products.
And they found as you age, the telomeres shorten.
Yeah, so aging has to do with shortened telomeres, and they're finding that if in species that don't age as rapidly, the telomeres are longer. Like I said, my last biology class was another too. But really fascinating. Genetics of behavior, Richard Ellis, Linda Fried, talks about frailty and aging. Elizabeth Spelke is interested in where knowledge comes from, and really she's looking at what makes humans different from other animals. Right? Her initial hypothesis was that differences would show up in very young infants, and actually when she looked at behavior, she found that human behavior was not all that dissimilar from other animal behavior, so she had to start looking for other things. These people are looking at healthcare reform, specifically Arnold Relman and Marcia Angel, Michael, I don't know how you say that, Siddiq on AIDS and social change, Eric Lander doing math, genetics, and collaboration. He started out in math, but he realized that there was a connection to genetics, and then he really got interested in how different areas of science collaborate, and he does a lot on that. If you ever go to this page and visit it and you only have time to watch a couple of the videos, this is one that you should watch for sure. Her name is Nora Volkov. She's the current director of the National Institute of Drug Abuse. And her take on addiction is really fascinating. She's discovered that addiction has a whole lot more to do with reward than with avoidance. And she's one of the first people to look at addiction as a disease state rather than a choice. Because what she's found is by examining the brains of people who are addicted to anything, she herself is a chocoholic, she said. But chocolate, drugs, porn, whatever it is, whatever you're addicted to, all has the same effect on your brain. And she's looking at how your brain literally interrupts your ability to make free will decisions. And so we think about ourselves as having free will, but there's a part of the brain that controls that. And she's finding that addiction interferes with that. And so looking at it as a health issue. Richard Dawkins. Anybody ever heard of this guy? A couple of you? Has anybody ever heard of anybody else that I've shown up here on this list yet? No. Well, Steve. Dawkins is the world's most vociferous proponent of atheism. He grew up as a Christian, or grew up in a Christian household anyway, but at a very young age started questioning all the things that he was being taught. And when he learned about Darwinian evolution, he realized that he didn't need to believe in God. And so he totally changed from his Christian stance to being a very vocal proponent of the dangers, as he calls them, of religion, all religion. And he's a really interesting guy to listen to. He's got some definite flaws in his logic, but interesting guy. This guy talks about violence, language, and Twitter. He talks about, why are we free to say things online in anonymous chat rooms that we would not otherwise say. This woman, I might play her video here in a minute. I want to talk about her some more. Susan Desmond-Hellmann, absolutely a science leader. And then Michael Gazzaniga. I put all this up there to illustrate that more than likely, with the possible exception of Richard Dawkins, I didn't know any of these things. I did know about Richard Dawkins. I've studied his work. I didn't know any of these other people. Didn't know what they were doing. I kind of had a vague idea that some of this science was going on. But I think if you want to know what science leadership is about, it helps to know something about the people who are currently leading the field. And some of these people would unquestionably be scientific leaders, because not only are they doing cutting-edge science, they're also actually in leadership positions. Like Nora Volkov, the director of the National Institutes of Drug Abuse, and Dr. Desmond-Hellmann, who, when this picture was taken, was the chancellor of the University of California in San Francisco. She's a fascinating person, but we'll get to her in just a minute. But I wanted to ask that question. Are good scientists, oh, you don't see it here. Maybe I should move it to where you can see it. How do I do that? Well, let me just move it over. Are good scientists necessarily good leaders? And I wonder if you could answer that, if you could ask that question about whatever major it is that you're going into. Are good computer scientists, that's not fair, you're more IT. Data scientists, so sorry. Are data scientists good leaders? Well, then you're still in science.
Yes.
Glenn, what's your major? Finance? Why not music? You should be in music. Are good finance people good leaders?
That's cute.
What is it that makes somebody in a particular discipline a good leader? Now, we talked about Einstein, and he fits the mold of being a good leader. But can you think of somebody who was a good scientist, but not a great leader? Does anybody come to mind? Have you ever heard the name Nikola Tesla? Well, Tesla Motors, right? Yeah. Who is Nikola Tesla?
He studied electricity. He was a physicist.
He was a physicist. He kind of revolutionized the understanding of what electricity was all about, right? And invented just a crazy array of stuff. But he was a terrible manager of his own data, of the ideas that he had. He just didn't know what he was doing. And he ended up in the middle of a war, really, between Thomas Edison, who I think I have up here in a minute, who was a good leader and a good scientist, and George Westinghouse, who were at war against how you should provide electrical power to people. And Tesla was on the losing end of that battle. He ended up penniless, ended up just not recognized for the genius that he was. So I think the answer is no. They're not necessarily good leaders. Again, if I wanted to know the characteristics of a good leader, a good scientific leader, Google really helped. Type in characteristic of a science leader. Surprisingly, you don't find that much. Science leadership is not something a lot of people study. Maybe that should be a clue that it's a good area for somebody to jump into and start thinking about. But I did find this blogger who wrote the top 10 qualities of scientist leaders. And I kind of looked at these and I thought, yeah, I agree with those. And a couple of them really stood out to me, and I want us to think a little bit more about this. Now, we have like 3 hours tonight, right? Just kidding. I'm gonna get done pretty quickly. But I wanted to think a little bit more about so vision. I mean, that almost goes without saying. If you don't have some kind of a vision for what's in the future, what's coming next, 25 years down the road, you're not going to be a very good leader. Passion, you need to have some degree of intensity about what you're doing. Communication, I thought that was a good one. You all have probably heard some things about that, right? About how important it is, if you're going to be a leader, to be able to communicate and articulate what you're thinking and your expectations. The one I really thought was interesting was generous, and I want to focus on that a little bit. So we'll come back to it here in a minute. But also risk takers, I thought that was interesting. 4 and 5, I thought, yeah, and I knew that. I mean, obviously, if you're going to be, we mentioned a minute ago, if you're going to be a leader, you got to be courageous, you got to be willing to take risks. And part of that is resilient. When something goes wrong, what do? Fold up and leave town? Probably. But if you're a leader, you probably need to be a little resilient. Self-examining and adaptive. So every once in a while, you gotta kind of turn inward and say, am I where I need to be? You know, is this project where it needs to be? To ask the question, so what? That's so very important, because especially in sciences, it would be so easy for me to get wrapped up in a project and just keep going and going and going and going and never ask myself, is this going to benefit anybody? Or am I just doing it to learn stuff? And she says a good leader is somebody who asks, what is the purpose? What's the point? But has fun in the process. I've always had tons of fun in the science that I'm doing. And then persistence. Somebody doesn't give up. I don't know what the difference between persistent and resilient is. Probably. Does this seem reasonable? I mean, it seemed pretty reasonable to me. Anything you would add to this list? If you think about the characteristics of somebody who's going to be a leader in science, can you think of any words we ought to put on there? Seems pretty good to me. If you think of any, let me know and we'll add them. But I wanted to talk for a minute about risk-taking and being generous. When you think about failure, what does failure look like? Well, this guy would, by some means, be considered the picture of a scientific failure. And in other thinking, maybe not so much. This guy's name is Hwang Woo-suk. He's a South Korean cell researcher who was a pioneer in stem cell research. And he was the first person to clone a dog. But then he claimed to have cloned a human embryo. And that would have made him the first person to have done that as well. And then he said he produced a stem cell line, which was later determined to be fabricated. And so the first thing that happened was, I'm not clear on all the details here, but I think he was taking the eggs that he was using in his research from graduate students in his lab, which was highly unethical for them to be coerced into donating eggs for his research. And then some of the figures that he was putting out with these stem cells were thought to be maybe just a little too good, and it was determined that he was actually just falsifying and fabricating what was there. Well, he was the director of the lab, and he claimed that he didn't know any of this, that all of this had been done by junior researchers, and he shouldn't be blamed for it. But he was actually indicted for fraud in South Korea. But, you know, he, through the years, has maintained, I really didn't know any of this, I didn't do any of this, I didn't have any part of this misconduct. They made a postage stamp based on his work back in 2004, when it was still thought that he was on the up and up, and that he was the pioneer in all South Korea came up. And you may have heard of other cases like this. I actually, today I thought, well, maybe I'll give you some other instances. And I started Googling some interesting scientific failures that have happened in history. And I got really depressed as I was going through that. I mean, it was a strange experience because, you know, here's one story. There was a researcher, I'm totally blanking on where now. It seems like maybe it was Harvard, but I don't want to say that for sure. It might not be. But he was looking at the effects of, correct me if I'm wrong, but MDMA on monkeys. Now, what is MDMA? It's a drug, right?
Pure ecstasy or whatever.
Ecstasy, that's what it is, yes, ecstasy. And he found, now, I'm sure nobody in here has any experience with that, but he found that ecstasy given to monkeys in certain doses was exceptionally harmful. That it killed 2 of the monkeys that it was given to within just a few hours. Published the results, and it as soon as it came out, major news organizations latched onto it. You know, they were here up until then. Ecstasy had been considered as sort of a safe recreational drug, no known side effects. And here we have proved ecstasy kills, right? Only, it turned out that his samples were tainted, and what he was giving them was not actually MDMA, but methamphetamine. And so he proved conclusively that methamphetamine is a deadly recreational drug. But we already knew that. And so even in that case, they've gone back and forth as to who's to blame for this. He said it was the manufacturer of the drug that was supplied to the lab had mislabeled the drug, and they claim no, the drugs were fine. So, you know, something's wrong. But they got at that story by not being able to replicate the results, right? They tried the experiment again, didn't work. You may have heard that there are people who believe that there's a link between early childhood vaccinations and autism. Now, where does that come from?
A bad story.
It comes from a single researcher who claimed to have found a connection, but what journal article what journal was that research published in? Right. It was never published. This is the most remarkable scientific blunder that I can think of in recent history. There are generations of people who believe that vaccines cause autism. And why? Because this guy, who has very dubious results, had a press conference before he published anything in scientific literature. And as soon as he had the press conference, the story went worldwide. Vaccines cause autism. And ADHD. Although that wasn't ever even part of the research. Somehow that got tacked on. And people are now not vaccinating their children because they believe that if they do, their children will get autism. And so children are dying of whooping cough and other terrible diseases because they're not being vaccinated because they might get autism. It's insane. Now, the question is, though, when it comes to leadership, what do you do with that? You know, there's failure in science and then there's failure in science, right? I mean, if you do an experiment and it doesn't work, that's one thing. Now those guys, the stories that depress me, that evoke a physiological, emotional reaction in me, they set out to defraud me. I mean, they set out to, for whatever reason, present faulty science as if it was true, mainly to make money. Thomas Edison is a great example of the other way to fail, the right way to fail. His famous quote is, "I have not failed." He's talking about inventing the light bulb. "I've just found 10,000 ways that don't work." And that's exactly the right attitude to have. But think about what goes behind that statement. 10,000 different things to try that don't work. And I like some of these other quotes attributed to him. "Many of life's failures are people who did not realize how close they were to success when they gave up. Our greatest weakness lies in giving up. The most certain way to succeed is always to try just one more time. Just because something doesn't do what you planned it to do doesn't mean it's useless. Opportunity is missed by most people because it is dressed in overalls and looks like work." And he said, "I never did a day's work in my life. It was all fun." Edison invented the light bulb, right? But Edison had a really significant failure in his career that we don't hear about. I alluded to it just a minute ago. Tesla, you remember? Tesla came up with a way to transmit electricity cheaply. Now, Edison was already doing it. Edison had already wired up New York City with power transformers that were based on direct current. And the problem with that was that he needed a transformer about every block or so. So they'd have this sort of electrical substation every block where they were trying to transmit power. Tesla's method used alternating current, and it was much cheaper and much easier to deliver, much easier to transmit long distances. But the problem with it was that it's nominally more dangerous. And that was Edison's point. He said if you expose yourself to electricity, DC versus AC, you can expose yourself to way more DC voltage than AC voltage and still be safe. And so Edison started asking people, do you really want this killer in your home? If you put AC electricity in your home, it will kill you. To demonstrate this, he actually went around the country doing live demonstrations where he would expose animals to equal amounts of AC versus DC electricity. And the animals who got the AC, of course, fried. The DC animals were fine. He did this not just on small animals like dogs and cats, although he did use them. He went so far as to electrocute an elephant. Crazy. But he failed. We don't have DC power today. We have AC power. Westinghouse won. But Edison's philosophy was, I'm never going to give up. Still a great leader. If you think about it, risk and the possibility of failure is one of the key things that keeps us from doing anything great. And so the question of how do you get past that? How do you get beyond the vulnerability that you might need to fail? It's a whole area of research. And again, I got hooked on all these little tangents that I was taking as I was thinking about this thing. And I discovered, well, I'd heard about this, but it came up, a TED Talk by a woman named Brene Brown. Has anybody heard of her? What is it, Brene Brown? Yeah, it's really good.
She's a researcher in like psychology.
She's a psychological researcher. What's the fundamental
Shame.
shame?
Yeah.
Yeah. She talks about shame, and she talks about the need for vulnerability. So if you get a chance to watch her TED Talk on vulnerability, it's really remarkable. Now, let's go back to Susan Desmond Hone. Because when I was thinking about generosity, I think this is such an important point about leadership. A scientist normally thinks, in my opinion, of their science as being extremely important. And that almost implies a kind of self-centeredness, that my work is the only thing that matters. This lady is a remarkable individual. She graduated with an MD degree. She went to become, well, she was just a project supervisor for a year or so. But in 1996, she was made the chief medical officer of a company called Genentech. And then in 2004, she was made the president of product development. By 2009, she was earning $8 million a year as the president of product development. She had hundreds of thousands of stocks in Genentech worth $95 per share. And she and her husband decided that they needed to do something more significant with their life. Her husband's a physicist, so he's a good guy. She resigned at Genentech to become the chancellor of UCSF. And in part of her work at UCSF involved going to Uganda and treating babies there with the disease just went totally out of my mind. It was specific. What was it? Not Ebola. It was something along with something indigenous that they were. But anyway, she went down in salary from $8 million down to $450,000 a year as she did that. 2 years ago, yeah, I'll just take that guy. 2 years ago, she became the CEO of the Gates Foundation. But the thing that her colleagues say about her, definitely a powerful woman. But I like this quote that the chief of hospital medicine said. You read her CV and you don't expect what you see, which is that she is disarming. She is so nice that people may wonder whether she is tough enough. She is. Let me see if I can get this thing to play for you. I think you've heard it. If I can figure out how to do this or see. Oh, except you may not be able to hear it.
Aspire to bring out the best in my colleagues. I think that's my goal as a manager, is that if I work with someone, that somehow I help them see what they're good at. One thing I loved about the way my parents thought about being parents of 7 children is that they had a really great ability to point out what each of us were good at. And as managers, I think often, and scientists and doctors are thought to be bad managers, and I'm trying to disprove that. But I do think a common fault of a manager is to point out people's failings or point out their mistakes. I first became interested in science because my dad was a pharmacist. And not only going to the drugstore, hearing my dad's stories at night at the dinner table, but then eventually working in the pharmacy with my dad, I wanted to be like my dad and was interested in math and science like he was. And so from an early age, I knew that I wanted to actually be a physician from a very young age. that was the part I remember most strongly, is him taking out a mortar and pestle and doing what I guess an old-time pharmacist might do, which is compounding and making specific remedies. I also remember very clearly my dad counseling people, walking to the side of the pharmacy and having private conversations. And over time, I wasn't only interested in the medicine part of it, but I was very interested in the people part of it and how my dad connected and helped people as a pharmacist. It is really hard work to lead a public institution in the middle of a recession. It's enormously challenging. And so my hope is that if I help create an environment that brings out the best in the faculty, staff, and trainees at UCSF, that the world will be a better place. And I honestly believe that. My husband and I go on our bikes, we ski, we get outside, and I find at work I'm a much more effective leader and colleague if I'm happy. If I get exercise, if I enjoy my time outside of work with my husband. And so what gets me up in the morning is thinking, boy, I'm really going to enjoy that run. I almost backed into science by moving from caring for patients to working on Taxol, a new cancer drug in the early 90s, and then went into biotech. So when I arrived at Genentech, I became very close to the scientists because I was intrigued by what they might bring me for products. And the closer I got to the scientists, the more I wanted to pull out of their labs new medicines for patients. The best thing about being in translational science and in product development or new medicine development is that you're never a solo artist. And to be successful, if you're leading a team, you're more like an orchestra conductor. If you're participating in a team, you're more like a member of an orchestra. Each part has a role. Each part is actually essential. And the symphony, or the medicine, doesn't end up being wonderful without each member contributing. We often take for granted that people will care about what we do or love what we do. And I think that's a mistake. Scientists need to be very effective at telling our story. Why should society invest in science? We need to make it really clear the value of science and the value of innovation in particular, particularly at a time when there's a big public debate about resources. There are skill sets and there are technical aspects to leadership and management that are just as important as learning how to take out an appendix. And I think the biggest watch out for talented, successful people who are scientists and clinicians is that they don't think they have something to learn about leadership and management and that it will come naturally. So I consider myself a student of leadership and management. I aspire to be good at leadership and management, and I have to work at it.
I think that was interesting. What did she suggest about leadership that you heard?
Sure.
And that's a really interesting point right there. I'm going to come back to that in just a second. What else?
She's a more effective leader and she's happy.
Yeah, I'm a more effective leader when I have been exercising, when I feel good.
So the importance of working well with people and bringing out the best.
She saw the value in herself doing what she could to help others bring out the best in themselves, right? I think that's a really powerful statement. She said, being a good leader is like being what? Orchestra conductor, right? Like you're in charge of all these parts that are moving, but you're pulling together the symphony. Go back to what you said a minute ago, Steve. You said personalities.
Well, she said that she's found that leaders, really good leaders, point out that the things that people they're leading are good at rather than what they're failing at.
That's exactly right. Have y'all heard of an assessment called Strengths Quest? Has anybody here done Strengths Quest? Have you all done it? As part of this thing? No. So what is Strengths Quest? Somebody tell me who's done it.
It like goes through and you'll get like 5, like they've got these little like cutesy words and stuff like woo. Woo is one of the words.
Are you woo?
I am woo. Yeah. And so like, but there are these different words, and they just kind of talk about. It's a little test that you take, and it gives you back these words, and each word kind of gives a description of like, you know, maybe a side of yourself, or maybe how you might operate in certain situations, and kind of gives some definition of those, and it also kind of gives a little bit of advice on how you can kind of maximize those, how you, like, you know, what kind of people you work well with, what are ways that you might be annoying, what ways you might be difficult to work with, what ways you might be good to work with.
Yeah, and so finally I have some hope. You know, I recognize that I am a poor leader, especially when it comes to science stuff. I don't know what it means even. I mean, this talk is the first time I've ever thought about leadership in science. I've just it's never come to my mind before. And I guess I've thought about leadership, but not really formally. But when I think about that principle, that a good leader is somebody who can bring out the best in others. Somebody who knows something. I think you said something about personalities.
Yes.
Yeah. Somebody who can understand personality, right? Somebody who understands the strengths that other people operate from. And somebody who operates from their strengths. That's kind of the whole point of Strengths Quest, is that you need to know your top 5 signature things so that you can operate out of those strengths. So like for me, my number 1 strength was input. Anybody else have input as a top 5? No? Okay, then you're not going to understand this at all. But it was almost impossible for me to create this presentation. And to finally say, okay, I'm ready to go over there. I mean, I left my office at 5:57. You know why? Because I didn't feel like I had enough information. I never do. I never feel like I have enough information. It's excruciating to try to get me to make a decision. Because I never have enough information. I always have to keep gathering information before I have enough. But that's one of my strengths. It sounds like a weakness to you, I know. But it's actually one of my strengths because I gather as much information as I can and then make a deliberate decision. So if you haven't taken that analysis, I would strongly encourage you to do it. I'm pretty sure there's a way that you can do it through the school for nothing. Isn't that right?
Yeah.
I don't know how to do that, but I'm pretty sure. You know, another route would be the Myers-Briggs personality types. It's good to kind of know what your personality is, what you operate from, so that you can realize how you will lead others and how others will respond. And like I said, that's my only hope, because if I have any leadership potential or ability at all, the only hope I have is being able to understand how people work and try to relate them. So whether or not I can do that effectively, and that's what I would offer you, is to be able to understand who somebody is and be able to understand how to help them, as she said, become the best version of themselves. Okay, I'm going to throw it open for questions. I've talked way. What, y'all have any questions? That's how this is supposed to work, right? I talk for a while and then you ask questions. Okay, it's your chance. Or throw out some comments.
Who's been one of the greatest leaders in your life?
Been one of the greatest leaders. That's a hard question. There's been a large number of them. I'd say I take cues from different people for different reasons. When I think about communicating, my karate instructor is probably the guy that I would go to for that. Excellent communicator, really knew how to tap into people's strengths and get them to feel good about themselves and feel like they can do what they need to do. So that's where I would go with that. My thesis advisor, John Wixlow, is my example of a scientific leader. He's at least as scatterbrained as I am and has his fingers in projects all over the place. And certainly I've had some youth ministers and people like that who I would consider spiritual leaders who kind of opened my eyes as to deeper spiritual questions. What else? Yes, sir.
You might not consider yourself a leader, I guess, in some ways, but when you are the chair of the department, you have to, lead other faculty, or at least one other faculty.
One other faculty.
But I would say as a professor, you are a leader of the students you have in your class. What are ways that you deal with speed bumps come the way, maybe times where the leadership or the knowledge or the understanding or whatever whatever it is maybe insufficient, or what are ways that you kind of move past obstacles in your leadership?
That's a good question because, as the chair of a two-person department, you certainly do encounter some obstacles in setting of a larger university. And I would say that number one is to not take myself very seriously. That's one thing is I think most decisions that are being made on a day-by-day basis are just really not going to be all that critical 15, 20 years from now, despite what we want to do. And certain decisions definitely are, right? I mean, the patterns that we create for ourselves set a tone for how our lives will work. But those little road bumps, sometimes you just have to look past them to realize, I could get all bent out of shape about this, and I could throw a fit and try to wield my power, or I could just kind of go with the flow and believe that these things are going to work themselves out. Usually they do. Sir.
I always like asking this question. What's one piece of advice you wish you would have learned when you had when you were our age?
There are so many things I would tell young Alan. I think that might be it. Don't take yourself so seriously. I really did tend to take myself very seriously as a joke. And I've probably missed out on a lot of joy by doing that. Having a sense of humor of things, about things is a really good idea. But I would say, I'll put it this way. Let's see, how old are you?
20. Almost 20.
Almost 21. When did you turn 20?
Just April.
April. Okay, so by the time I was your age, I was married. My wife, who's still my wife, my first wife, it was a nursing student, and I was a physics major. And we got married in between the fall and spring of my junior year, her senior year. She's in really. That would be the other advice. I would go after older women. I have never regretted that. I know I got married really young, and you know, none of the people around me were getting married that young. But it was really good. And again, this comes from taking myself pretty seriously, you know. So now I'm kind of going back on that advice. It was good for me to know myself well enough to know that this is what my future was going to hold. And there was no reason not to embrace it. So that was probably pretty contradictory advice, wasn't it? Sorry about that. Anything else? Well, I hope it's been reasonably helpful for you. If not, it's all Dr. Weingart's fault. Tell him you did Dr. G.